Preparing for a senior analyst interview at Goldman Sachs interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Walk me through your recent project and explain the technical decisions you owned as a senior analyst. I would frame the project around the problem first, not just the tools. For example, I owned a reporting platform that reduced manual reconciliation for operations teams. I designed data validation checks, optimized SQL pipelines, and exposed results through APIs. I chose simpler batch processing over streaming because the SLA was hourly, not real-time. The key impact was fewer breaks, faster investigation, and clearer ownership across technology and business teams. While answering, focus on business context, your ownership, architecture choices, measurable impact, trade-offs, collaboration with stakeholders, and how you handled ambiguity or constraints in delivery. Question 2. How would you design a trade reconciliation system for front office and back office data? A reconciliation system compares records from 2 or more sources and highlights differences that matter. I would ingest trades from front office and settlement systems, normalize identifiers, then match using trade ID, account, product, quantity, and economics. Tolerance rules handle small acceptable differences. Unmatched records become exceptions with audit history and ownership. I would make ingestion idempotent, store lineage, and prioritize breaks by financial risk, regulatory impact, and settlement deadline. Make sure to cover source ingestion, matching keys, tolerance rules, exception workflows, auditability, idempotency, data lineage, SLAs, and how reconciliation breaks should be prioritized. Question 3. Explain how you would optimize a slow SQL query used in a daily risk report. I start by reproducing the issue with realistic volume, then inspect the execution plan. I look for full table scans, bad join order, missing indexes, and expensive aggregations. If the report filters by date or desk, partitioning and composite indexes can help. I also remove unnecessary columns and push filters earlier. After tuning, I compare row counts and totals against the original output because a faster report is useless if the numbers change. In your answer, talk about execution plans, indexes, joins, filtering, aggregation strategy, partitioning, statistics, avoidant functions on indexed columns, and validating correctness after optimization. Question 4. What is the difference between inner join, left join, and full outer join, and where have you used them? An inner join returns only matching records from both tables. A left join keeps everything from the left table and fills missing right side values with nulls. A full outer join keeps records from both sides, matched or unmatched. In reconciliation, I often use full outer joins to find missing trades. In reporting, left joins are useful for optional enrichment. The main risk is duplicate joins from non-unique keys, which can inflate totals silently. Be sure to mention matching behavior, null handling, use cases in reporting or reconciliation, duplicate risks, join keys, and why choosing the wrong join can distort business metrics. Question 5. How would you handle missing, duplicated, or inconsistent records in a financial data pipeline? Financial data pipelines need controls, not hope. I would define mandatory fields, uniqueness constraints, valid value checks, and cross-field validations. Duplicates should be detected using business keys, not just technical IDs. Bad records can go to a quarantine table with reasons and timestamps. I would alert owners, support replay after correction, and track recurring issues. The best fix is often upstream, so I document patterns and work with source teams. While answering, cover validation rules, deduplication logic, reference data checks, quarantine tables, alerting, root cause analysis, replay mechanisms, and clear communication with data producers. Question 6. Describe how you would design a REST API for retrieving client positions and balances. I would design resource-oriented endpoints such as get/client/ID/positions with filters for date, account, asset class, and currency. Responses should be paginated and include metadata like valuation timestamp. Authentication verifies the caller, while authorization ensures they can access that client. I would avoid overcaching sensitive balances unless freshness and permissions are clear. Good APIs also expose meaningful error codes, correlation IDs, and logs for supportability. Make sure to cover endpoint design, filtering, pagination, authentication, authorization, caching, data freshness, error codes, observability, and protection of sensitive financial information. Question 7. How do you approach debugging a production issue during market hours? During market hours, my first goal is containment, not heroics. I identify business impact, affected users, recent deployments, and whether data integrity is at risk. I check logs, dashboards, and upstream dependencies before changing anything. If rollback is safer, I recommend it quickly. I keep stakeholders updated in plain language. After service is stable, I perform root cause analysis and add monitoring or tests so the same issue is harder to repeat. In your answer, emphasize incident triage, impact assessment, logs and metrics, rollback decisions, stakeholder communication, temporary mitigation, post-incident review, and avoiding risky changes under pressure. Question 8. Explain multithreading and concurrency issues you would watch for in a trade processing application. Concurrency helps process many events faster, but shared state creates risk. In trade processing, two threads updating the same position can cause incorrect exposure if locking or transaction boundaries are wrong. I prefer immutable messages, thread-safe queues, and database constraints for final consistency. Thread pools should be sized based on workload, not guesswork. I also watch for deadlocks and ordering requirements, because processing faster is dangerous if trades are applied in the wrong sequence. Be sure to mention race conditions, locks, deadlocks, thread pools, shared state, immutability, transaction boundaries, ordering guarantees, and why correctness matters more than raw speed. Question 9. How would you model trades, accounts, instruments, and positions in a relational database? I would separate transactional data from reference data. Trades store execution details, account ID, instrument ID, quantity, price, trade date, and status. Instruments hold product attributes, while accounts represent legal or client structures. Positions can be derived from trades, but many systems store snapshots for performance and audit. I would use foreign keys where practical, indexes on reporting filters, and effective dates for changing reference data, like ratings or classifications. While answering, focus on entity relationships, normalization, primary and foreign keys, reference data, historical changes, indexing, audit columns, and reporting versus transaction processing trade-offs. Question 10. What data structures would you use to detect duplicate transactions in a high-volume stream? For exact duplicate detection, I would use a hash set keyed by a transaction identifier or composite business key, such as account, amount, timestamp, and reference ID. In a stream, I would apply a time window, so memory does not grow forever. For very high volume, a Bloom filter can reduce memory but allows false positives. Critical financial flows usually need exact checks, backed by persistent storage and idempotency keys. Make sure to discuss hash sets, composite keys, time windows, memory limits, false positives, persistent storage, idempotency keys, and the difference between exact and approximate deduplication. Question 11. How would you explain the difference between market risk, credit risk, and operational risk to a technical interviewer? Market risk is the risk of loss from price movements, such as rates, equities, FX, or commodities changing. Credit risk is the chance a counterparty fails to meet obligations. Operational risk comes from process, system, people, or control failures. As a technologist, I connect these to data quality, calculations, workflows, and controls. A delayed feed, wrong model input, or failed approval can become a real financial or regulatory issue. In your answer, define each risk clearly. Connect them to systems or data. Use financial examples, and show why accurate, timely technology controls matter in banking. Question 12. Tell me about a time you had to influence stakeholders without direct authority. I once needed several downstream teams to adopt a common file format for regulatory reporting. I did not manage them, so I built a simple impact analysis showing duplicate effort, recurring defects, and missed SLA risk. Then I proposed a phased migration with backward compatibility. By making the change lower risk and tying it to shared pain, I got buy-in. The result was fewer manual fixes and a cleaner support model. Be sure to use a structured story, clarify conflicting priorities, explain your communication strategy, show evidence-based persuasion, and quantify the outcome where possible. Question 13. How would you ensure a critical batch job is reliable before it feeds a morning business report? I treat critical batch jobs like production products. I define upstream dependencies, expected start and finish times, data volume thresholds, and validation checks. The job should be restartable from checkpoints and safe to rerun without duplicating output. Alerts need to reach the right owner before the report deadline. I also keep a backfill procedure and a business communication template. Reliability comes from controls, not just a successful happy path run. Why answering covers scheduling dependencies, retries, checkpointing, validation controls, alerting, SLA monitoring, backfills, ownership, and clear failure communication before business users are affected. Question 14. What is idempotency, and why is it important in payment, trade, or order processing systems? Idempotency means the same request can be processed multiple times with the same final result. It matters because networks fail, clients retry, and message brokers can redeliver events. In a payment or trade system, duplicate processing can create real financial loss. I would use unique request IDs, database uniqueness constraints, and status checks before applying changes. The design should make retries safe instead of asking operators to manually clean duplicates. Make sure to define idempotency, explain retry scenarios, mention unique request IDs, database constraints, safe updates, duplicate prevention, and how it protects financial correctness. Question 15. How would you design access control for internal users viewing sensitive client or trading data? I would start with least privilege. Users should see only the data required for their role. Role-based access works for broad groups, but attribute-based checks help with desk, region, client, or legal entity restrictions. Sensitive fields may need masking unless explicitly approved. Every access should be auditable, especially for client and trading data. I would also support periodic entitlement reviews because permissions that never expire become a security risk. In your answer, talk about least privilege, role-based or attribute-based access, entitlement reviews, audit logs, segregation of duties, masking, approvals, and regulatory expectations. Question 16. Explain how you would calculate and expose P&L for a portfolio in a reporting application. P&L should be explainable, not just calculated. I would combine positions, trade activity, prices, FX rates, and instrument metadata. Realized P&L comes from closed trades, while unrealized P&L reflects current valuation versus cost or prior marks. The application should aggregate by portfolio, desk, product, and currency. I would expose drill downs so users can trace numbers to inputs and reconcile against official books before publishing business-critical results. Be sure to mention realized versus unrealized P&L, market data inputs, positions, pricing, currency conversion, aggregation levels, explainability, controls, and reconciliation with official books. Question 17. How do you decide whether to use synchronous APIs or asynchronous messaging between services? Synchronous APIs are useful when the caller needs an immediate answer, such as validating a trade before booking. Asynchronous messaging works better when tasks can happen later, like sending confirmations, updating analytics, or notifying downstream systems. Messaging improves resilience because producers and consumers are decoupled, but it adds ordering, replay, and monitoring complexity. I usually choose sync for request-response decisions and async for scalable event propagation. While answering, compare latency, coupling, user experience, resiliency, retries, ordering, observability, operational complexity, and examples such as trade booking versus downstream notifications. Question 18. Describe a time you improved performance, reliability, or maintainability of an existing system. I improved a nightly report that regularly missed its SLA. The first step was measuring where time was spent, and most of it came from repeated database joins. I introduced intermediate aggregates, added targeted indexes, and removed unused transformations. We tested outputs against prior runs before release. Runtime dropped from over 2 hours to under 40 minutes. The important part was improving performance without changing business numbers or increasing operational risk. Make sure to structure the example around baseline metrics, diagnosis, changes made, testing, rollout, measurable improvement, and how you balanced business risk during implementation. Question 19. How would you handle conflicting requirements from technology, compliance, and business teams? I separate preferences from constraints. Compliance or regulatory requirements are usually non-negotiable, while business and technology requirements often have implementation options. I would document the conflict, clarify impact, and propose alternatives with cost, timeline, and risk. If needed, I escalate with facts rather than opinions. A senior analyst should not just take orders, they should help teams make informed decisions and keep the delivery aligned with control expectations. In your answer, discuss requirement clarification, risk-based prioritization, documentation, escalation, trade-off analysis, regulatory non-negotiables, and aligning stakeholders around measurable outcomes. Question 20. Why Goldman Sachs, and why are you a strong fit for a senior analyst role here? Goldman Sachs appeals to me because the technology work is close to high-impact financial decisions. I enjoy systems where correctness, latency, controls, and business understanding all matter. I bring experience translating requirements into reliable solutions, working across teams, and improving existing platforms without disrupting users. At senior analyst level, I would add value by owning delivery end-to-end, asking strong risk questions, and communicating clearly with both engineers and business stakeholders. Be sure to connect your motivation to Goldman Sachs, engineering rigor, financial domain interest, ownership, collaboration, risk mindset, and examples proving you can operate at senior analyst level. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.